Okay, so these rational expressions are algebraic fractions. And we're going to start by simplifying, and then we will get into adding and subtracting and multiplying and dividing them. This can get a little tricky if you don't pay attention, so just make sure with this unit that you're focused. The simplifying is not hard, and the multiplying and dividing is really not hard. It's when we get to the adding and subtracting, those are going to be harder, because, adding and subtracting fractions, common denominators, all that good stuff. But we're going to just start by simplifying, and the very first thing we want to do is, if anything can be factored, we want to factor this, because when you simplify fractions, you can only simplify factors. Those are things that are being multiplied together, not things that are being added and subtracted. So you can cancel factors, not terms, and terms are separated by plus and minus signs. So if we're looking here at both 1 and 2, do I have any plus or minus signs anywhere? Yeah. Okay, so nothing is going to be able to be factored here because it's a single term over a single term. So we're going to start these like we've done before, and we're going to start with just the numerical parts. Okay, so let's start with the 24 and the 32. What I want to know is, do 24 and 32 have something in common that I can divide out? They can divide out a little bit more than 4. 8, okay. What is 24 divided by 8? 3, and 32 divided by 8 is 4, okay. So that 24 turns to a 3, and the 32 turns to a 4, because we divided both by 8. And then we just look at the variables individually. Do you guys remember me asking you where do we have more, top or bottom? Those stay there. Okay, same concept here. If I look at my x's, I have 5 x's at the top. I have 2 at the bottom. Where do I have the most? At the top. So my extras will stay at the top. And how many extras do I have? 3. So that's going to be x to the third. And then we do the same thing with the y's. I have 7 y's at the top. I have 12 at the bottom. Where do I have the most? How many more do I have down there? 5. Okay. So like I said, we've done this a little bit before when we were simplifying with our exponents and stuff, but this is just rational expressions, so we shouldn't have any exponents involved other than what's on the variables, not like in parentheses where we have to get rid of. Does that make a little bit of sense? All right, go ahead and try 2 then. Start with the numerical values. What can you divide out of those? What do you have in common? And then do each variable individually. Where do you have the most? Those are going to stay there. All right, what is it that negative 20 and 25 have in common? 5. Okay, so negative 20 is going to turn to negative 4. 25 turns to 5. And then if I look at my A's, I have 5 at the top. I have 10 at the bottom. Where do I have the most? How many more at the bottom? 5. Okay. And then B's, I have 3 at the top and I have 3 at the bottom. So when they're exactly the same, what do they do to each other? Just cancel out. And then I do have a C at the top and I don't have a C at the bottom. So what does that mean that C is going to do? Just stay at the top. Okay. And that is as far as we can simplify that. Is everybody kind of okay with those 2? Got a couple people still writing. I'm going to wait just a second. All right. Now 3 and 4 look a little bit different. Because now we have some parentheses with multiple terms. And again, when we start these, the very first thing you're always going to ask yourself is, can I factor any part of it? Can I factor the numerator? Can I factor the denominator? If you can, you're going to need to factor it, because what we need to do is we need to see what factors it is made up of, because again, we can only cancel factors, not terms, things that are being multiplied. So if I'm looking at number 3, how many things, different things do I have multiplied at the top? I have 4 times what? Y minus 8 and times y plus 7. So there's 3 factors at the top. The 4, the y minus 8, and the y plus 7. Those are things that are being multiplied. And in the bottom, I have 8 and then x plus 7, or y plus 7 and y plus 8. Can any of that continue to factor? It looks like it's already been factored a little bit. Can any of it continue to factor? We have binomials. The only way we can factor binomials is if they're perfect squares or perfect cubes. Do I see any squares or cubes up there? No. Okay. So since it's already factored for me, all I have to do is go through and simplify every piece. Let's start with the numerical values in the front. 4 and 8. What can those both divide by? 4. Okay. So that 4 is going to turn to a 1. The 8 is going to turn to a 2. Do we see any other factors at the top and the bottom that are exactly the same that might cancel each other out? The y plus 7. I've got a y plus 7 at the top. I've got a y plus 7 at the bottom. So therefore, I can get rid of those. I can divide them out just like we divided out the b to the third and the b to the third. Is there anything else exactly the same? No. So what I'm going to do then is I'm going to write at the top the leftover pieces, the y minus 8. And at the bottom, it is y plus 8. Now, I can leave my answer like that, but is that 1 really necessary at the top? No. So what I could also do is I could just leave it as y minus 8 over 2 times y plus 8. There is no need to distribute that 2. You can if you want to. Like you could do it y minus 8 over 2y plus 16. However, there's no need to create more work when we don't have to. You can just leave it as 2 times y plus 8. Does that make a little bit of sense? Okay, then try 4. Again, some of these will be already factored for us, so all we have to do is get rid of the same factors. Can anything in number 4 continue to factor? No. Okay. What we need to do is start simplifying. Now, I do have a numerical value in the denominator of 3. Do I have a numerical value at the top that I could reduce with that? No, so that 3 is going to stay at the bottom. What do you see is the same? So I can cancel those out. And what's left at the top? Okay. You can put the parentheses around it, but because there's nothing multiplied by it, you don't have to. Either way would be fine. Is there anything else I could simplify there? So we'll leave our answer just like that. Does that make a little bit of sense? Okay. All right, I want you to try 5 and then hold off on 6 because we're going to have to talk about that one. Can anything be factored in number 5? No. Do we see anything? Let's start with the numerical values that are in the front, the 7 and the 5. Can those simplify at all? No. So I'm going to leave them where they are. Do we see anything else that's exactly the same? What? 3y minus 1. Okay. At the top, I'm left with what? 2y plus 1. And at the bottom, I'm left with 2y. Can I cancel the 2y at the bottom with the 2y at the top? No, the 2y at the top is being attached to the 1. It's a term inside of parentheses, so therefore we cannot simplify. You can leave your answer just like that. You could also leave it like this. Or if you wanted to, you could leave it like this, okay? I probably would just leave it the first way just because it's less work to do and leaves for less room for error. Okay. Now let's take a look at 6. At the top, I have 2t minus 1 and t plus 2. And at the bottom, I have 4t plus 8. So again, the very first question we need to ask is, can any of that be factored? Look at the numerator. Can anything there be factored? No. What about the denominator? What can I do to those? I can pull out a 4. Remember the GCF? And if we pull that 4 out, what am I left with? T plus 2. Does that help me simplify anything? Does that give me stuff that's the same at the top and the bottom now? What? T plus 2. Okay, I'm going to get rid of the T plus 2's. At the top, I have that 2t minus 1. You can put it in parentheses if you want, but there's nothing else up there, so you don't have to have the parentheses. And what's left at the bottom? 4. Can I reduce the 2 and the 4? No, that 2 is attached to the t, which is attached to the 1. That is a term, so therefore we can't simplify. If that 1 wasn't there, or the negative 1 wasn't there, if it were just 2t over 4, then we could simplify. But because of that minus 1, there is nothing else we can do with that. Everybody kind of okay? All right, take a minute and, well, I want you to try 7. It is very similar to 6. Number 7 is very similar to number 6. What can we do to the denominator there? Pull out a what? A 3. So that's going to turn into 3 times t minus 7. So what can I get rid of now? What's left at the top? And at the bottom? 3. Can't simplify any of that because nothing is a factor that has anything in common. All right, let's take a look at number 8. I got t to the 3rd minus t over t minus 1. We are going to have to factor here because in this problem, nothing has been factored. So let's start at the top. Keep thinking back to when we factored. What was the very first thing we looked for? GCF. What is it that t to the 3rd and t have in common? Okay. So that's going to give me t times what? T squared minus 1. The denominator is just t minus 1, so it cannot simplify. Am I completely factored yet? No. Look in the parentheses at the top. What are both of those numbers? Perfect what? Squares. So we can continue to factor that a little further. I'm going to keep the t at the front. And remember, with perfect squares, we set up our 2 parentheses. We take the square root of the first term. What's the square root of t squared? T, so that goes in the front. And then we take the square root of the last term. What's the square root of 1? 1. And then what about my signs? What do I put? 1 of each. Yep, 1 plus, 1 minus. Is that completely factored? Can I break any parenthesis down any further? No. Do we see something that we can simplify now that we have it all factored out? What's the same? T minus 1s. And if I cancel everything out of the denominator, do I have to put it over 1? No. Can I put it over 1? Yes. So we can leave it as t times t plus 1 over 1, or we can also just leave it as t times t plus 1. And yes, if you wanted to multiply that back out and give me t squared plus t, that's also fine. But again, why do more work when you don't have to, right? How are we feeling about these? As long as we can remember to factor, they're not hard, right? It's just the factoring part. All right. If we look at number 9, can I factor either one of those? Do they have a GCF? That's where we're first starting. No. It's only 2 terms, and they're not both perfect squares or perfect cubes. However, what do you notice? They're exactly the same. So can I just cancel the whole 2y plus 9 with the whole 2y plus 9? And if I do that, if I'm able to cancel everything that's in the problem, what's left? 1. If everything cancels out, you will just get it. You can leave it as 1 over 1 if you want, but it is also more simplified to just be 1. Okay, so that happens sometimes. Even on some of these problems where you have to do a lot of factoring and then everything can cancel out, you could end up with just 1 as your answer. All right, let's start with 10 and don't let 10 trick you. At the top, I have x squared plus 4. First question, do they have a GCF? No. They are both perfect squares. However, they are perfect squares that are being added. We can only factor perfect squares if they are being subtracted. So can I break down x squared plus 4? No, I can't. Okay, so I'm going to have to leave that just like it is. What about the denominator? Can I do anything there? I can pull out that GCF. What is it they have in common? Okay, and that's going to leave me with x plus 2. Does that help me simplify anything? No, there's nothing that is the same at the top and the bottom. I cannot simplify either of the 2's with the 4 because those terms at the top cannot be simplified. So there's nothing I can do. I can either leave my answer like this, or if you recognize it from the beginning that nothing's going to cancel, you can also leave it like that. Either one of those answers. Okay, nothing can simplify even when I factor it. Are we kind of okay with those? Okay, I want you to start with 11. What I want you to do is I want you to factor top and bottom. Okay, think about factoring the top and the bottom with in number 11. These are trinomials, so first things first, we got to remember how to factor. Want to try to factor x squared plus 19x plus 60. And then we want to factor x squared plus 8x plus 16. Looking at the top, do we have a GCF in any of those terms? No. So let's remember factoring now. We want numbers that multiply to give me 60 and add to give me 19. Two numbers that multiply to give me 60 and add to give me 19. Numbers that multiply to give me 60 and add to give me 19. If we're not sure, we can make a list. 15 and 4, yes. 15 and 4 multiply to give me 60, and they add to give me 19. Remember, if my second sign is a plus, that means my signs are going to be the same, and they will both be whatever that first sign is, so they are both going to be plus. Then we want to do exactly the same thing at the bottom. All three terms do not have a GCF. So what I want are numbers that multiply to give me 16 and add to give me 8. What numbers multiply to give me 16 and add to give me 8? 4 and 4. Are my signs going to be the same or different? Same, and they're both going to be plus. Can that factor any further? Do we see things that are the same at the top and the bottom that we can get rid of? Here's the thing, and I have this happen every now and again, not a lot. How many x plus 4s do I have at the top? 1. That means I can only cancel 1 at the bottom. So I can't take that x plus 4 at the top and cancel out both. It's 1 for 1. 1 at the top and 1 at the bottom. So I can cancel out one of each, top and bottom. And then I am left with, at the top, x plus 15. You can put it in parentheses if you want, but there's nothing left to multiply it by, so it's not necessary. Same thing at the bottom, x plus 4. Can I cancel out those x's? No, they are terms. They are being added to another term, so there is nothing else I can do to that besides leave it like x plus 15 over x plus 4. Is everybody good with that? I got one more. It's a little bit harder on the factoring, so I'm going to give you some time to work on it. Okay, we got numbers in front of x squared, so that means it's going to take a little bit on the cloud method, so that whichever one you prefer, you can see, hopefully. All right, so remember the very first thing is we want to list the factors of 15, so 1 and 15, and 3 and 5, and listing the factors of 2 or 1 and 2, and that's it, right? Are we trying to add or subtract in this problem? Look at the side. So we're trying to subtract, and we want to subtract to get what numbers in front of that x? A 1, right? We talked about if the middle term was odd, you can't use a pair of even factors. If the middle term is even, you can't use a pair of even odd factors. My middle term in this case is 1, which says I can't use a pair of even factors. But if I'm looking at my factors, I don't have any of those, right? Okay. And then what else did I tell you? Which ones do we usually not try first? The bigger ones, the 1 and the 15. So what I'm going to do is I'm going to start with 3 and 5 and see if I can get that to work. So I'm going to put 3x and 5x. And I'm going to put my 1 here and my 2 here and just see if that works. And we might have to switch the 1 and the 2. We have to just do our multiplying. And when we deal with these, remember we're checking the products of the outside 2. What's 3 times 2? 6. And then we multiply the inside 2. What's 1 times 5? 5. Do 6 and 5. Subtract to give me 1. They do. So that means I've got it right already. We just have to now figure out our signs. If my second sign is a minus, that means my signs are going to be different. And the first one goes in front of the bigger number. What's bigger, 6 or 5? 6. So in order for that 6 to become negative, where do I put it? In front of the 1 or 2? Did I multiply 1 to get 6 or 2 to get 6? 2. So it's going to go a minus here and a plus here. Is everybody okay with that part? Okay. Let me do the cloud method real quick. So if we wanted to do the cloud method on that one, remember we pull the 15 off. We keep the x squared minus x, and then we multiply 2 times 15, which gives us 30. Then we can factor it like this. What numbers multiply to give me 30 and subtract to give me 1? Different signs, bigger numbers, so minus 6 plus 5. And then what do we do with that 15? We have to bring it back where? Under these two? Okay. And then we're going to simplify first. Do 5 and 15 have something in common? Yeah, I can divide each one of those by 5, which leaves me with 1 over 3. And then what about 6 and 15? They can both divide by 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. And then what do we do with those numbers in the bottom? Put them in the front. So that becomes 3x plus 1. And that one becomes of x minus 2, which is exactly what we got with the guess and check, right? Okay. All right, in the denominator, we have 5 and 6 that we're dealing with, and we're trying to subtract to get 13. The only factors of 5 are 1 and 5. Factors of 6 are either 2 and 3 or 1 and 6. So I'm going to try the 5 and the 1 with the 1 and the 6. Oh, let me try 2 and 3 first. I don't like 1 and 6 first. I'm going to try 2 and 3. You could try 1 and 6 first, but I like trying the smaller numbers. What does that give me? 15. And what does that give me? 2. Does 15 and 2 subtract to give me 13? It does. I need different signs, and then I need my bigger number to be positive. So that 15 needs to be positive. So where's that going to go, in front of the 2 or the 3? Where did I get 15? From multiplying 5 times 2 or 5 times 3? So I got to put the plus there, which means the minus goes there. And I'll do that one on the board too with cloud method. Okay, so pull the 5 off. Multiply 6 times 5, which gives me 30. Numbers that multiply to give me 30 and subtract to give me 13. Different signs, bigger number. Then we bring that 5 back in. This one cannot reduce. 2 and 5 don't have anything in common. But 15 and 5 do, and that reduces all the way. What is 15 divided by 5? Just 3. And then I bring that 5 to the front. And I end up getting exactly the same factors as I got with my guessing and checking. What can I get rid of now that I'm finished factoring? What's the same? 5x minus 2. So at the top, I have the 3x plus 1. At the bottom, I have the x plus 3. Can any of that be simplified any further? No. Okay, so the factoring might be a little bit